Oğlu'nu sahneye davet ediyorum. Kendisi hem bu genel değerlendirmede timle kısa bir sohbet yapacak, ardından sizlerin sorularınızı koordine edecek. 4 soru hakkımız var. Çıkarken de kulaklarınızı teslim ederken biraz sabır gösterip sessiz olursanız çok teşekkür ederiz. Görevli arkadaşlarım burada mikrofonlarıyla olacaklar.
Okay. Well, thank you very much being here today with us. If you allow me, I'll just speak a little bit in Turkish.
I can get a translation.
Maybe we can. Okay. Çok kısa bir şekilde ben özetlemeye çalışayım. 2009 senesinde Tim'le ilk defa tanıştık ve Çin'deki projemizle ilgili olarak çalışmaya başladık. Ama hayalimizde olan yapıyı gerçekleştirmek için yol üzerinde keşfettiğimiz sadece mimari ve tasarıma, mühendisliğe karşı olan ilgimiz değildi. Aynı zamanda Çin yemeklerini de beraber keşfettik ve o konuda da özellikle İpek Böceği'ne kadar giden yolda bayağı bir uğraştığımızı söyleyebilirim beraber. Bununla beraber şunu da sormak istiyorum aslında. Bu Çin'de yaşadığımız bu tecrübeyle paralel olarak aynı şeyi bir başka şekliyle Türkiye'de de yaşadığımızı düşünüyorum. Her ülkenin kendine göre bir mimarlar ve mühendisler arasında iletişimini sağlayan ve mimarlara hayallerinin sınırını çizen bu mavi kitaptan birazcık bahsetmek istiyorum. Yönetmelikler konusu ve sınırlamalar hakkında Çin'deki konuşmalar ve çalışmalar esnasında bununla özellikle çok karşılaştık. Bunu mimarlar ve mühendislerin beraber aşabileceğine inanıyorum. Bu konuda neler söyleyebilirsin bize?
Burn the books. Burn the books. Yeah. The books come after. The books come after, okay? This is the thing I learned, you know. This is the thing that's been the most exciting thing to learn, that you can actually think things out from first principles. And in fact, it's absolutely vital to think things out from first principles to be alive. And regulations are fences. They keep you in and they keep you out, okay? So if you're going to be an adventurer, if you're going to find out about the outside or the inside, you need to understand the fence and you need to respect it. I'm not really advocating anarchy, but what I am advocating is that the responsibility of having to think something through entirely yourself is a very refreshing, revealing process. And it made me understand why the engineers in 1880 or 1890, well, they didn't have the book either. They didn't have the blue book. They were writing the book. But when the book is written, we had a prime minister called Harold Wilson. And he talked about the white heat of technology. Right? When you're very focused on a particular aspect of technology, and everything at that moment becomes visible, everything becomes articulate, everything becomes emergent. Then the focus changes and the white heat becomes white noise. Okay? White noise is something that you put in an open plan building to suppress all the observations. So you can't hear any particular voice. And the regulations can put us to that sleep, you know. So the regulations also, the number of engineers who say, how were you allowed to design this glass structure? How were you allowed? The funny thing is that the building inspectors in England, let me speak about England, they say, you prove it, give me an argument, and take responsibility, and you can do it. The Germans don't say that. Yeah, nothing's, we can seal it. When we did the first Apple store, we designed the glass bridge, we designed the glass balustrade. We'd done all this stuff before, so we knew it worked. Sealy, we thought, great contractor. So we showed them the design. They said, nah, no, it doesn't work. Nothing works. We said, well, are you mad? Of course it works. And they said, no. So, yeah, no, we need to test this, we test this. Everything they tested, which was brilliant, actually, because, you know, they verified our design, which was good. But it's what you need to do in Germany. You need to actually, if it's not been done before, you actually demonstrate through a test that it works. So I think you have a different requirement in every country, and I think you need to meet them in a different way. But the thing is to be brave, I guess.
Soru sormak isteyen?
Merhaba, İsmail Kösen benim ismim. Ben mühendis değilim, ben mimar da değilim. Benim bu binalara bakış açım gerçekten çok heyecan verici binalar. Yani seyretmesi bile çok güzel. Tabii içinde olmak daha başkadır. Şimdi benim bu binalara bakış açım şöyle. Ben bu binaları hayata geçtiğinde, yani yaşama geçtiğinde bu binaları canlı tutacak çözümler. Örneğin teknik olarak destekleri vermek, işte binanın temizliklerini yapmak gibi bir takım unsurlar. Bu konularda nasıl çözümler üretiyorsunuz? Çünkü o binayı yaşatacak insanlar gerçekten bu konularda zorlanıyorlar. Ülkemizde bunlar çok maliyetli şeyler. Yani binanın yapımı da maliyetli, yaşatmak da çok maliyetli. Bu konuda nasıl çözümler üretiyorsunuz? Çok teşekkür ederim.
Yeah, I only work for rich clients. It's absolutely right. And if you ever go to the Apple store in New York, the Cube, you know, there are guys there all the time cleaning. But you know, I mean, this is a funny thing, but I like to clean my windows in my house. It's been there for the glass in the windows. Some is over 100 years old. Still there. You can see the wave in the glass. And I like to get some water and some vinegar. And 2 cloths. I do first with the salt and the vinegar, then with a clean one, and then with this lovely little rubber. And it looks like it looked 100 years ago. So that's the magic of glass. Do you want to clean it? I don't know. Do you want to spend the money cleaning it? Sure. How much? How often? I don't know. Do you have a car? Do you have an expensive car? Do people clean the car? Some do, some don't. The thing about glass is that it can get dirty, but it's certainly not getting less strong. It's not falling apart. It can crack. Sure, it can break. But one thing that I've been trying to promote, and I don't know whether I will be successful, but you take a piece of glass with 4 layers of glass, very expensive, and someone drops something on it, and oh my God. Actually, you don't need to replace it. It's all right. It's not going to fall down. Strong enough. But I need to educate you to believe that. Because you think, oh, broken glass, need to replace it. So it could maybe be a bit of changing in attitudes. But I hate to see a dirty canopy. I hate to see an overhead piece of glass that isn't cleaned. I'd rather they didn't do it, I'd rather, like you, I'd rather it was metal. Or do you have to think on something, which can not necessarily disguise? It's usually the horizontal planes are the worst. I mean, the vertical planes don't get it so bad. And every building needs windows. If you're cleaning that much or that much, you still got to clean it. So maintaining the vertical surface of glass and windows has always been a problem, always will be a problem. They have invented glass which is supposed to be self-cleaning, so it's okay. I don't know whether it's the universal answer, but this is what you need to think. Your question is the question that needs to be answered. You're asking the question that we all need to answer, and we need to answer you clearly, honestly, efficiently, economically. We need to do that. And it's important. And I think it's possible, you see. I believe it's possible. There have been lots of times when people have said, okay, the glass is okay for looking out, it's okay for the sun coming in, but environmentally it's a disaster. It's a disaster. We're spending all our money going out the window. So they're right. So what's the answer? I know the answer. It's vacuum glass. Vacuum glass. Does it exist? Yes. Can you buy it now? Yes. Will you be able to buy it in bigger sheets more economically soon? Yes. And it will have the same insulation value as 4 inches of polystyrene. So, I think these technical questions are the right questions, and they should stimulate a good answer. Thank you.
Adım Ali Eren Patan, çevre ve inşaat mühendisiyim. Bu benim cam kirişler oldukça dikkatimi çekti. Bizim betonarme kirişlerde gelen hareketli yükleri kolonlara iletmemize çelikler yardımcı oluyor. Ama cam kirişlerde bu camın lamine oluşturulmasında katılan kimyasalların bu yüklerin iletilmesine, aktarımına etkisi var mı? Ya da bu cam betonarme kirişlere nazaran bu kirişlerin istikrarı, hani sağlamlık açısından nasıl? Bundan pek detaylı bahsedemedik. Belki program süresi kısa olduğu için. Ve ikincisi de bu tamamen cam yapılarda bazı çelik kirişleri kaldırdığımızdan bahsettik. Şimdi bizim daha çok buralarda gördüğümüz örneklerde alüminyum alt konstrüksiyon olduğu için bir nebze betonarme ile alüminyum arasında membranlarla, kapamalarla bir şekilde yalıtımımızı yapıyoruz. Fakat su yalıtımı için yani tamamen silikon kullandığımız için bu ne kadar sağlam ya da daha değişik ilerletilmiş, teknolojisi ilerletilmiş bir silikon mu kullanılıyor? Sorum bu ikisiydi. Teşekkür ederim.
Okay, the first question, Yeah, this worried me when I did my first glass beam. Because I was confident that the glass itself will not be affected by chemicals. It can be affected by acid, of course, but in the materials like the silicone or for the laminating material, these will not affect the glass. But what I don't know is how long will the laminate remain in good condition? Will it deteriorate? How long will the silicone which holds the glass onto the beam, how long will it remain? So when I started these designs, these were still my questions, and through time I've now come to the conclusion that silicone applied properly to proper surfaces has a length of life which well exceeds any of the guarantees. You know, I've been using it for 25 years, absolutely no problems with it. And I have heard, and I do go to conferences and ask that question. I say, does anyone know of problems using silicone in either a structural form or as in the weathering form? I haven't heard any bad news. So I'm very confident that those materials will last a long time. I don't know whether, it wouldn't be as long as the glass, because the glass, unless you damage it by breaking it, really is pretty good and is likely to last 200 or 300 years. So, yeah.
Mikrofonu.
Strüktürel cam üzerine çok güzel örnekler gösterdiniz. Hakikaten mimar olarak bizlerin ufkunu açtınız. Öncelikle teşekkür ediyorum. İki taraflı eğrisel çatıların kaplanmasında Çin'de yapılan son örnekte de gördüğümüz gibi üçgen modüller kullanıldı. Üçgen modüllerle bunun çözülmesi tabii daha kolay. Fakat siz ondan önce bir örnek gösterdiniz. İki eğimlere ayrı, iki kiriş üzerine oturan bir dikdörtgenin de onlarla intibak ettiğini, uyuştuğunu gösterdiniz. Bu benim ilk defa rastladığım bir şey ve çok da faydalı bir şey olacağını düşünüyorum. Sorum şu, yani eğrisel, iki taraflı eğrisel yüzeyleri böyle dikdörtgen modüllerle yapalım mı? Yani siz yapmışsınız zaten. Bu camda bir iç gerilmeler yaratıyor mu, yaratmıyor mu?
Well, you know, it's interesting, but for the Shenyang project, when I looked at the design, I said, everything is being welded. Why are you having a triangulated shape? And they said, well, because we can use triangular flat panels, always, to negotiate any degree of curvature. And I said that's correct. However, if you examine the geometry of one square and you press the glass like we did in the warped glass condition, you can make a square panel and push it into place. And I think there was about 85% of the roof could have been done in that way. Would have made the node much easier to fabricate. 4 members rather than 6. It made the glass easier to fabricate. It would have halved the amount of steel, silicon, aluminium. But they were on the train, right? So it wasn't a structure, they're going this way, so don't stop us. Don't stop us, we're going this way. But we could have done it. And I've always found the diagonal can be a problem architecturally, the diagonal. In a Mimarisi'nde building, it wouldn't be allowed, would it? That I know. Everything thick and ground or plain and vertical. So the Virendeel has always fascinated me as a wonderfully simple, easy to fabricate, and if used in the right configuration, say in the story height of a building, you can make big span, top and bottom beams, vertical columns, and add a diagonal if you need one, but not otherwise. So I think, the grid shell, it can take. The glass roof to the Apple store was reciprocal beams. I think I was trying to describe it that you get 3 knives and make a structure. Well, they don't need to be rectangular even. If you look at, you can put those systems together and the geometry is not rectangular. It's actually, as long as they follow the system of borrowing off each other, you can create, and you can vary the surfaces as well, Particularly flat plate. If you take a flat plate, cut it like that, and then join them together to that one, and then very easy you make.
Merhaba, ismim Gökhan Esen. Binalarda camın bir fonksiyonu da binanın yalıtımını sağlamak. Bu da çok önemli rol oynuyor. Bilhassa Apple'ın binası gibi binalarda tabii ki mekanik ısıtmayla bunu da çözebilirsiniz belli bir oranda. Fakat camda bilhassa çift cam uygulaması yapılmamış olan uygulamalarda ekstra bir çalışma yapılıyor mu yalıtkanlığı sağlamak için bilhassa güneşe karşı da? Ben özellikle bunu merak ettim bilhassa Apple binası için.
No, the Apple stores, the Apple stores have not pursued the sustainability issue at all. No, there's no interest in doing it, primarily because, like most shops, I've got single glazing, laminated but single glazing. They're mostly concerned about you seeing the product. And their advertising budget would easily, the air conditioning isn't costing them so much money, so they don't worry. But for me, sure, it's like so keen to get find it's like it's the holy grail really of what we're looking for. Okay, we've got strength. Okay, and not a problem. As strong as you like, can do any kind of structure. But it's got to be 2 things. One is it's got to be completely insulated against radiant heat. But it's also got to be able to completely reflect back incident radiation. So that if we have... It's got to be a switchable wall, but whether it's switchable in itself or whether it's always using it with something external. I mean, from an architectural point of view, I think it's actually really interesting to think about what you use outside the wall to stop the sun coming in. But ultimately, the ultimate wall is a double vacuum with a U value of nothing 0.1 watt per square meter, double vacuum, which you can get. The vacuum space only needs to be less than a millimeter. Less than a millimeter. So you can actually use very thin glass. You wouldn't even think it was like a gap. You just think it's... As long as you can keep the glass apart and you can suck the air out of the gap, it doesn't matter what size the gap is. Okay? So you've got a very thin sheet, and then all you got to... This is the bit. I mean, they've got switchable glass. They coat the glass with chemicals and switch it on or switch it off. I mean, I'm sure you've seen it, translucent. So you need to be able to grade it from translucent to opaque. Yeah? From clear to translucent to opaque. And then you're there. It's not too far. We're nearly in the last mile. We're not too far away, really. And then, what else would you put in it? Why would you put anything else in a building? And then you make it self-cleaning, of course. We're going to make it self-cleaning. It's light. It should be there forever. Why else would you, I mean, if you build a brick wall, you can't see through it. That's stupid, isn't it? That's really stupid. You want to see through a wall, don't you want to see? At least have the option. So, glass is the only thing that can do that, right? There.
Kısa bir soru. Başlıklardan bir tanesi soğuk bükme ile alakalıydı. Cold bending. Mr. Macfarlane acaba birkaç kelime söyleyebilir mi cold bending hakkında?
Yeah, the cold bending. If you've got a piece of glass that's got to fit onto a surface which is not flat, then to bend the glass into a permanent shape in an oven with heat is so expensive that you probably wouldn't do it. What we discovered when we did the cable wall on that semicircular end wall was that you could let the cable deflect a meter. Now, when it deflects a meter, the piece of glass in the middle, or in fact, it's a piece of glass towards the edge actually, was being warped. So we thought, wait a minute. And then we looked at the numbers, and you can try it. You know, if you get a piece of glass and do it yourself, and hold 3 corners, and then see how far you can bend the other edge. Wear gloves. But if it's toughened, and you can get really highly toughened glass actually, much higher than industry, you'd be surprised how far you could bend that. And it doesn't break because it's within its stress limits. It's just deflection and stress. And it doesn't matter if it's stressed all the time. It's okay. Floors are. So it's a very good solution for doing complex curves economically. So you don't need to spend the money on expensive shaping. Evet.
Çok teşekkür ederiz. Bizimle birlikte bu heyecan verici deneyimlerini paylaştığın için. Aynı zamanda dinleyicilerimize de çok teşekkür ederiz. Bize bu fırsatı tanıdıkları için.
Teşekkürler.
Buyurun.
Ben zannedersem sizin sunumunuzdan bir parça çalmış
Lütfen.
olacaktım. Eğer sohbet anlamında devam etmeyi arzu eden varsa içecekler yan tarafta. Biraz saat belki geç oldu ama
Bizim konferanslarda böyle bir durum söz konusu. Sağ olsunlar bu saatlere kadar bizlerle kalıyorlar. Ve yine küçük bir hatırlatma yapmak istiyorum. Olur ya İzmirli dostlarınız, öğrenci arkadaşlarınız, akademisyen arkadaşlarınız, iş arkadaşlarınıza bilgi vermek istersiniz. Yine Tim Macfarlane'in bu konferans konusu yine Yapı Endüstri Merkezi, ERA, bu sefer İzmir Ticaret Odası ve İzmir Ekonomi Üniversitesi işbirliğiyle 14 Ekim Cuma günü İzmir Ekonomi Üniversitesi'nde gerçekleşecek. O konferansta da buradaki İstanbullu takipçilerimizi orada da bekleriz. Tekrar çok teşekkür ediyoruz. Önümüzdeki günlerde davet edeceğimiz mimar ve tasarımcılarımızı yemetkinlik.com sitesinden de takip edebilirsiniz. Herkes ikram alanına davet ediyoruz. İyi akşamlar.
Okay.